Hello everyone, thank you very much indeed for coming out on an October evening. We're really delighted to have you here today, partly because this is such a wonderful new venue and I'm really pleased that we were able to get it for this evening. Jo and I have worked together for several years now and I'm really pleased that she's agreed to take on this TED Talk for us. The thing about Jo is that not only is she really incredibly well informed, incredibly bright with a huge background in science, but that she takes the time to make that understandable for the rest of us. And so for this kind of TED Talk, I think that's absolutely perfect, and she's the perfect person to do it. So I'm going to hand over now and introduce Professor Jo Martin.
Thank you. Thank you ever so much for that. Having said that I'm comprehensible, I think my family would probably disagree. So if you don't understand, please feel free to look bewildered and to go, if you don't understand. So today I'm going to talk about one bit of pathology. So pathology comes in 17 different bits. Some of them are aggregated in the handouts you've got there. And we look after you from before you're born till after you die. And we also look after your pets. So one of our 17 different specialties is genetics. Genetics, genomics. And I'm going to talk about one particular aspect of that industry, and particularly emphasis on the industry. So there is a plethora of genetic testing available to you on the internet. Some of my favourites are here. There are some ones that you may well recognise. So the 23andMe, the cryogenetics, are direct-to-consumer products that will give you ancestry information. They will give you health risk scores based on your DNA. But there's also some interesting other ones, which will give you vitamin supplements based on your genome, fitness advice based on your genome, and a wine tasting recommendations based on your genome. Venome. There isn't a genome as far as I'm aware at the moment, but it's only a matter of time. So there are a range of different products out there. So how do you choose? Do you choose? So who here has either done one of these or has thought about doing one of these? Yes, so quite a few of you, and I've thought about doing it too. Just another quick poll. Who here has had a genetic test? Who all thinks they've had a genetic test? Actually, okay. Who has been born in the UK, Australia, America, Western countries? Hands up here. Okay. So all of you who thought you hadn't had a genetic test have. So at 6 weeks old, you will have had a blood spot test. And that tests for genetic conditions. It doesn't test DNA, it tests the products of your DNA. And we screen for genetically transmitted diseases that can be essentially prevented or made better through early diagnosis. So there are newborn screening genetic testing. So you will have had that done. And not many people realise that. So there's quite a disparity in what people understand about what a genetic test is. And these direct-to-consumer tests are part of a whole spectrum of different ways of analysing your genome. You can analyse your genome through what those genes produce, like the proteins. So I know that I have a genetic condition because I had a blood test which says that there's a thing called alpha-1 antitrypsin deficiency. And I'm going to come back to that. I know my mum had it. I had it. I have it. I don't know whether the kids have got it. But that's a genetically inherited condition. But I know that through the protein, not having had my DNA done. More of which later. So in having a DNA test, in having a DNA test, or wanting to have one, or thinking about having one, you are not alone. Globally, the number of DNA tests sold has doubled every year for the last 4 years. It's up to about 25 million, that's according to Genetics Digest, which is an industry organisation. So this is huge business, huge business. These kits are being given as presents. People are buying them. We were asked last year by a president of an East Asian pathology society what we were doing about over-the-counter DNA testing, because they were being given as gifts, with teenagers were giving them to each other as gifts. So I'm going to move on a little bit to, well, yes, it's nice to buy one of these kits, but are they any good? So what's good? What would good mean to you? What sort of things, if you have a test, it's good, what would that mean? It's accurate? Consistent and accurate. Thank you. So, consistent. This is a pair of identical twins. And they sent their DNA off to 5 ancestry companies and came back with 5 different results. Not wildly different, but 10 to 25% different. Identical. And confirmed as identical through sequencing. So why do 2 people with identical results come back with different results? So let's go to Bake Off. So you can start off with identical ingredients. You can follow roughly a recipe, but you may do it in a slightly different way. So you might over-knead your dough. You might, not mix in your currants properly. So there's a technical aspect to a DNA test. And then you end up with a product. And the product will then go through a series of basic platforms that you can almost think of as an oven. And you end up with a product. And that product will come out of the oven, and then it gets judged. And that's what they call algorithms. And it gets, when you judge something against your own experience. So if you've got Paul Hollywood, or you've got Mary Berry, or you've got Prue Leith looking at your buns, they've got a huge amount of experience, and they know what a good bun looks like. So that experience is brought to bear on judging your bun, whether it's a good bun or whether it's a bad bun. But that experience, they'll say, we don't like that one. That's not a good bun. That's a bad variant. But if you don't know your buns, if you don't have a broad experience of buns, you're not going to be a good judge of buns. Now, I know I'm labouring the bun analogy a little bit much here, but it's the same with genetic testing. So if you were given your genome, if you were given all your DNA bases from one of these tests, and they test 690 to 700,000 little snippets of single nucleotide polymorphisms, little changes in your DNA. They'll test 690,000. Do you think that's a lot? Seems like a lot. Do you know how many you've got? 3 billion. So as a proportion, it's about 0.01, less than 0.01%. So it's not a huge proportion of your genome is being tested by these kits, or by most DNA tests, to be fair. So when you're testing those and you're looking for variants, you're looking for problems or potential problems in your DNA, you can't do it on your own. If you gave a sequence on the floor, you wouldn't be able, it wouldn't mean anything. It would be a list of words. And unless you could speak the language, unless you could compare it with the right spelling, you wouldn't know that there was a wrong spelling. So when we talk about data for genetics, there isn't really anything such as personal data, because you're interpreting your data in the context of everyone else's. And we know that a particular group of people with breast cancer have this change in their DNA. And we know that a particular group of people with alpha-1 antitrypsin deficiency have this change in their DNA. And so you can only interpret that change in the context of what's happened before and where disease is associated with a particular change. With me?
Yeah.
Excellent. So what's really important in this is that experience. And what a lot of our genetic databases don't have is much in the way of ethnic diversity. So there's been a family in the United States that was diagnosed as having a potentially harmful heart disease, and they were followed up and the whole family was tested. And as it transpires, the change which is associated with disease in a white background is actually very common in a normal population. It's about one in 4 people have that change in a completely normal black population. So your genes need to be in context of your background, your experience with that population, and increasingly that importance of your background genes, your background genome, is being appreciated. And again, when you're looking at what tests you should prove, that background population, that background data is so important for the interpretation, correct interpretation. You know, I could choose that bun as being really rubbish, but actually when you look at it, you know, everybody else's buns might be exactly the same and it doesn't actually matter. So interpreting your changes in the context of that association, really key. The other thing is some of the changes that are picked up by this particular technology, so when you use a chip-based rather than a base-by-base technology, it can pick up variants that can't be validated. So when you're talking about reliability, when you talk about accuracy, it can pick up changes which you then can't prove again. Now, can you imagine a patient coming to you saying, I've got this DNA test, I've had this, and I've got a risk for breast cancer. And the thing is, you're not going to forget that you've been given a result that says you've got a risk for breast cancer or early onset Alzheimer's disease or alpha-1 antitrypsin deficiency. So you're not going to know, you're not going to be able to unknow that. And that information is going to stay with you. And then you go to your GP, because that's your, you go, I'm really worried about this. I've been told I've got a risk for breast cancer. And they talk through your family history, and you've got no history of breast cancer. And then you worry. And then you might get referred to a genetic counsellor. And the genetic counsellor will send you for a validation test. And that validation test will go through your genome using a different sort of technology. And they will say, it's not there. Who do you believe? And that's what's happening to patients now. We know that some of these over-the-counter tests, or over-the-internet tests, are more sensitive but less specific than conventional testing. So they're coming up with what are called false positives. So that false positive is really troubling. There are figures from between 50 and 70% of the variants of the risk-bearing variants on some of the chips cannot be validated. So really difficult stuff. The other thing is some of these testing are very they're very qualified in the text. So when you get a piece of kit, when you get a new piece of tech, when you get a new fridge, when you get a new phone, how many of you read the small print? Yeah. So I was going through one of the commercial products and was about to click the add to cart, 149 quid to have my ancestry and my DNA done. And then it says, tick, I accept the terms and conditions. There's a little box, I accept the terms and conditions, pay now. So I clicked on the I accept the terms and conditions. I clicked on the terms and conditions button. And I'm going, whoa. And the terms and conditions and the detail behind it, the devil is in these details. When you are buying this, do not buy this lightly. If you have a genetic test from a genetic counsellor, you will have a lot of detail going on. You'll have informed consent. You do not have a genetic counsellor with these. So, there's detail on the websites of these tests talking about different types of genes. The other thing for the breast cancer gene, if you had one of these tests, would you expect it to pick up all the breast cancer genes associated with the BRCA gene? So yes. So you would sort of expect that it would pick up all of it. Doesn't. It's only validated to pick up a couple of them. So you can be falsely reassured if you don't read the detail. The other detail here on the bottom right-hand side, talk to your healthcare provider to determine if comprehensive genetic testing is appropriate. Well, is this not a comprehensive? It isn't. And that's what necessarily is not clear. It's offered as a product, but actually it doesn't do what you think it does. It does what it says it does, but you assume it will do more than it does. So again, be careful with these. I've put this off because I knew you would understand this straight off. So, monozygotic, twins. So, I used the example of twins earlier, and this is another example of twins. So, we know that there's a disease called motor neurone disease. Have you heard of that one? Yeah. So it's also called amyotrophic lateral sclerosis in the States. It causes a progressive and irreversible degeneration of the motor system so that you can't move. Both your upper motor neurons and your lower motor neurons that control your muscles die. It's horrid. And currently there are very, very limited treatment options for it. There are some familial forms of it which are associated with gene defects, gene changes. This, even though it's complicated, basically is saying that if you have twins or identical triplets, the chances of them having an identical disease are limited. So the chances of you inheriting the disease, you can inherit the gene, but you don't necessarily have the disease. And that's, again, let me just explain with buns. You can have the same product and it can end up with two different options. So I have inherited alpha-1 antitrypsin deficiency. I am not diseased with it yet. I don't have, as far as I know, liver disease, and I don't have lung disease that can be associated with that gene defect. My mother didn't have liver disease or lung disease that is commonly associated with that. So I have a defective gene, but I don't have the disease. And those twins, they may have, one of them has the defective gene and the disease, and the identical twin has the defective gene but no disease. Genes are there. So you have a bookcase full of genes. Who has a cookery book that has not been read? That's a bit like your genes. So you've got it and it's completely unused. You haven't read it, it's not done anything useful. It's not done anything damaging, it hasn't produced some weird, horrible creation that nobody likes. But that's the same as a gene. So a gene will sit there, but it only becomes active under certain conditions. So a lot of your phenotype, so what you show to the outside world, how you operate, is through that control of genes. So just because you've got a variant that is potentially risky doesn't mean to say that you're going to develop the disease. And it says that in the small print. So when you go to these genetic tests, you will have lots of variants. Some of them will be risk-bearing, some of them won't. The fact that you can modify your gene expression, so you can change your gene expression very easily. You can go for a run, that will change your gene expression. You can eat too much, that will change your gene expression. Just a touch, just a simple act of touch will activate probably in the region of 5,000 genes just in your nerve cells. So everything you do, everything you eat, everything you breathe, your activity levels influence your gene expression. So your genes are not everything. Those books stay on them. Some of them get used, some of them get used on special occasions. You know, I've got people coming round to dinner, better get the dessert book out. But a lot of them will stay there unused, and that's where your variants will not matter. So, still thinking about having a direct-to-consumer genome test? There are upsides. They're available. They're cheap, relatively cheap. And if you are interested, they are there. It gives you choice. But for the sake of pathologists, for the sake of the healthcare services in general, make that an informed choice. Understand, read the small print. Thank you. Questions?
If there are questions, we'll pass the microphone around and let you ask your question from Joe.
Hi, thank you. That was really interesting. My question is regarding the data that is collected.
Yes.
You might get the data.
Yes.
I might not know what to do with it.
Yes.
Might cat or tail of it. But somebody's got that data as well.
Yeah.
Right? What happens to that data?
It stays.
It stays.
It stays. So again, it's a balance. It's a balance between the community needing that data to make sensible decisions about other people, but also most organisations will want to refine their algorithms, those choices that they make as to whether something's bad or good. For a lot of, if it's a commercial company, they'll want to use that data essentially more broadly to broaden their population coverage, to broaden their ancestry data. There are very few gypsy bloodlines in there. There's very few, the whole of Iceland's been genotyped. The whole of the population got genotyped. So that data, unless you wish to withdraw it, read the terms and conditions. I haven't seen anything that says you have the right to withdraw your data. You have the right to a copy of your data for a lot of these databases, but I haven't seen the fact that you can withdraw them. So in the health services, if you ask to withdraw your data from your health record, you have that right. It's very difficult to do, don't get me wrong, but you do have that right. Did you think that was what was going on?
I honestly didn't know what to expect.
Yeah.
What they would be doing with that data.
Yeah.
I would have been quite paranoid.
Yeah.
When they sell it,
Yeah.
What happens? I have no idea.
Yeah. I mean, that's a thing about big data in general. So there are certain supermarkets that can predict flu seasons in advance of the public health data because the sales of cold and flu remedies start to go up. So your data can be used in a range of different ways. Sorry, there's one at the back there.
Hello, I want to thank you, and a little bit about reading the small print. Is it the responsibility of the companies to educate the population more, or is it the responsibility of us as consumers to be more educated about all the products we get involved with?
Yeah. Okay. So I would say it would be both. Some people. So there is essentially a moral responsibility on a company to be honest, and public opinion. Social media now is very good at holding people to account. So shaming bad practice is much easier than it was writing an angry letter to the Times before. It's much easier to do that, and generally the companies will respond to comments. There are education programs, but to be honest, if you go on the website, it's not read all about our services first, it's buy our product. And it's literally here, buy now. Press the button. It's dead easy. Press the button. And that's the balance. Do you really know what you're buying? And part of our mission as pathologists is to try and help educate people about what's going on, what they're buying, what they're doing. You know, I don't want you to go home worried because, you know, because you've bought a kit and you've had a test and you don't know what the, you know, and it's come up with something you don't expect. And often these things you just don't expect. Even if you think you expect it, if it comes up with a thing that you're going to get later onset Alzheimer's disease, which it won't, it will tell you you're at risk of developing later on, or you have a variant that is associated with an increased risk. You'll read that as I'm going to get Alzheimer's disease. And you, again, as I say, you can't unpick it. So go in knowing. Because the other thing is, if you've got genetic information about you, does your brother have it? Does your sister have it? Do your kids have it? So, yeah. Jean.
Do some of the tests, do they affect your insurance? So if you think you may have more likelihood of something, things like medical insurance or travel insurance might be influenced by that?
So in the UK currently they're not allowed to use genetic data. There is one exception, which is Huntington's disease, but that may change. That you have to declare, and that's a legal framework. There is a general agreement that knowing about that is a bad thing, but not all countries have the same rules.
Okay, thank you.
Let's go the front here.
Jo, fabulous talk. Do you think a professional body, or perhaps the college, should have a position statement on these home tests? Is it timely for us to do that?
So, perhaps we should. Perhaps we should say, again, read the small print, know what you're doing. These are, so I think we've flagged some sensible sites to talk about it. And there's a Genomics England education programme as well that's open to the public. And you can learn more about your genetics. I mean, sometimes it can feel like a jump off the high board when you're starting to get to grips with it because you don't know the language and you don't understand even the basics. But it is doable. You know, I can learn it. You can learn it. It's not, I was going to say it's not rocket science, but it isn't rocket science. It's genetics. And you can learn, and there's lots of resources out there. I think we've flagged some of them there. I think the college, I mean, again, some of the people who are providing these tests are our members. And they are getting better. And they are getting better, but again, it's commercial. They are selling 25 million of these things. And people are coming into the health services saying, ooh. So we need to just ensure that there's good practice going on. Sorry.
Thank you very much for your talk. So as you say, people are going to start coming into the health service wanting confirmatory tests. Clinicians are going to have people showing up on their doorstep saying, oh, my test says I've got this, that and the other. That's then putting a burden on the NHS.
Yes.
And I can only predict, surely, that this will kind of increase in the future. Is there, or should there be an onus on these companies to provide a bit of their profit back into the NHS if they're kind of causing this havoc, making money from what seems like exploiting people's inherent health anxieties, for them to then profit and put that burden back on the NHS? Is there anything that can be done to stop that from happening?
Okay, so some of the companies will argue and with some, potentially with some justification that they're helping people discover risk traits that they can prevent later disease. So if you discover that you've got a gene tendency for high lipid levels, familial hypercholesterolemia, that is a treatable condition, and if you discover it, you can treat it with drugs and stop later heart disease. So the companies will be saying we're helping the population become more healthy. How much tax they're paying in this UK, in the UK to support the health services, I'm not an expert on that. Some others in the audience might be, but that's, you know, that's a condition. I think it's the responsible use of genetic testing and not over-promising. If someone discovers they've got a breast cancer gene that you can't validate, that's a problem. And we've got people doing that now. So our geneticists are having people turn up to surgeons who go, I've got the BRCA variant, I want a mastectomy. And they go, well, hang on a minute, that's on the basis of this particular test. Well, you hope that they're going, and then they refer them to geneticists, and then they'll go through the database, and then they'll find that it's, you know, it is a risk variant, or it's not a risk variant. So it's having to validate people who are otherwise well. So there is, you know, some of it is genuine prevention, but some of it is difficult to validate. And that's as I say, it's a technological variance. That, you know, if they all provided to the same level that we would do as validation testing, it would be too expensive to. So it's a quick and inexpensive route, but it creates a lot of ripples, and it covers a small amount of your genome and selected variants. So again, it's you get what you pay for.
Hi, thank you for
Hi.
the talk. I just wanted to ask, do these tests take in epigenetic tags into consideration?
No.
And if not, how
Okay.
could they do that? Is there a possibility?
Okay, so epigenetic tags are a little, it's like be quiet. A little be quiet signals that sit on your genome. So when we were talking about the motor neuron disease, a lot of those genes will be, your genes get sort of wrapped up, and then they get chemical changes that keep them quiet. And that's what epigenetic tags are. I hope that any real geneticists in the audience are not hating me at this moment, but it's oversimplification. And basically, no, it's a DNA single, it's an SNP, it's single nucleotide polymorphism testing. There are some companies which are looking at epigenetics, methylation patterns as part of their offer. Not the most common ones, and not all those signatures are yet validated at clinical level. So those epigenetic signatures may be coming into use in some tumours, but are not widely used, and you have to be very specialist to interpret those. So not over the counter as a routine thing yet. That's just a whole nother forest to go through. That sounds like we're going on a bear hunt, you know, we go to, yeah. Sorry, at the back there, back right. So gentle with a genetics degree, I'm taking a step backwards on this one.
I shan't be asking any questions about genetics.
Oh, good.
I've got two questions. They're
Sure.
related but quite separate in my opinion.
Okay.
Right. You haven't really talked very much about regulation, either in the UK or around the world, and
Yes.
you know, differences from one country to another and way in which countries actually operate cooperatively.
Yes.
Would you like to comment on that first?
So there are differences in, obviously, in regulation, and certain countries have got state to state. So in the US, state to state that regulation differs also. Much the same as cannabis legalisation. It's legal somewhere and not others. There is regulation about which variants can be reported by, for example, 23andMe. The FDA allows them to report certain variants, but not all variants, based on the technology that they're using now. And if you read the website, they talk about selected variants. There is a degree of regulation around consumer protection and MHRA regulation around medical devices. So there is that envelope. Again, differs country to country though, and in some countries there's very little in the way of regulation.
And what you're saying is, in terms of the substantial variation that you can pick up even within the UK, that is perfectly acceptable to the authorities. So that if you go to one tester, you get one set of results, and if you go to a different tester, you get different results, and that's considered acceptable.
Currently, there is no bar to it. Bear in mind, more generally, genetics and genomic studies have increased exponentially over the last few years, and quality control within that is we've been doing clinical biochemistry, and we've got really tight clinical biochemistry. If you have a blood test, the parameters within the variation in that is minute. The variation, because of the technical difficulties around this and the technical complexity around DNA testing, we're not quite at that tight level of QA, so there is more intrinsic variation and variation in that interpretation. There are some studies around variation in cancers. So gene changes that you get in cancers can be used as the basis on which to provide certain drugs. So, receptor levels, estrogen sensitivity. You might have heard of a drug to treat associated with a change called PD-L1 for lung cancer. So we can do genetic testing for those, but some of the gene changes in cancers can be only in a small proportion of cells. And the interpretation of that is really difficult and varies quite a bit. So they call it low frequency alleles. So the high frequency alleles, where you've got a tumour which has got lots of the same mutation in, then the accuracy is 98, 99%. Still not 100. But with a low frequency genetic change, the reproducibility between labs is much lower. And that's not on these direct-to-consumer tests, because they're not doing Cancer One. It's quality control around genetic testing in general. So some of it is technical difficulties. But the direct-to-consumer tests test your somatic, your ordinary, your germline ones usually from saliva, from cells, from DNA that you get on the inside of your mouth.
I think to some extent you sort of moved on to the second question I had, right, which is the reproducibility of results in public labs. Yeah. And you're saying that is really a function of the type of test that you're performing.
Yes.
but is the aim to try and get all labs to produce effectively consistent results that are reproducible?
Absolutely, absolutely. And we have, so within pathology, within most of our disciplines, we have so-called external quality assurance schemes, where we send a sample round and we get all the labs to test the same sort of sample, or the same sample, or a reference sample. And labs can examine their performance against other labs. And if they're off, if they're outside the normal distribution, they can look at what they're doing and why they're outside where they should be, basically. And that's part of routine. So all labs in the health service that are accredited, and the majority ones in the health service are, for testing, will have this quality assurance loop. So you can be sure that there are quality systems that go on. Doesn't mean to say there aren't errors. And 23andMe say there may be laboratory errors, and we know that laboratory errors happen. We know that some people have swabbed their dogs and sent them off, and they haven't been picked up. We know that some people have sent male swabs off as female swabs, and they haven't been picked up, that they haven't got a Y chromosome and things like that. So errors can happen, or people can try and skew the system, but the quality assurance, we're big on that at the college, about trying to ensure that people have got the right information and they've got a decent quality test. But they also know what they're getting. Was that? Thank you ever so much for listening, and thank you for coming. It's been interesting, and we can now perhaps break up and have a bite to eat and something to refresh ourselves. Thank you very much indeed.